So I thank the organizers, Serene, for inviting me to give the presentation. And I'm going to talk to you about virtualized infrastructures and security in virtualized infrastructures. And because of my background in computer networks, I will be giving the presentation or the talk from a networking perspective. I'm an associate professor at the School of Information Technology at Carleton, and I have done most of this work with my graduate students. So what I'm going to talk to you about today, and I try to keep some concepts in the presentation in abstract form, because we're talking about networks, very complex systems, and there's a lot of details. So there are times where I'll be showing you an example of a network. I'm only showing the functionalities that I am interested in this particular slide. So whenever you see something presented, I'm focused only on the functions that I want to talk about. So I will briefly talk about what is a virtualized virtual infrastructure, a virtual IT infrastructure. Then I'm going to talk about SDN, software-defined networking, which is the core concept in this talk. And then I'm going to talk about examples of new security issues. I'm using this presentation as a way to give an introduction to what we do in the networking community and how this is actually going to impact how we think about security. As I mentioned, I do most of this work with my students. So I like to start by acknowledging their contributions to my research. I also lead the Next Generation Networks group. So almost all of our work is posted there if you'd like to get more information about it. And there is a link to it from my webpage. You don't need to remember the link. So the first thing I'm going to start with is what is a virtual infrastructure. And I want to start with this because it means different things to different people. So whether you are using a virtual machine to run your favorite software, or you are running an experiment and instead of buying an expensive test bed, you come up with a virtual test bed, or you're using cloud-based applications, the virtual infrastructure will come into the picture. So this is not a formal definition, but there are things that are listed here that are usually involved. The first thing is virtual machines or containers. And when we look at virtualized infrastructures, clouds, virtual middle boxes, network slicing, there are many things that actually came into play in order to allow people to move into this direction, which is the direction of basically getting computing, providing computing, or consuming computing as a utility. It's not a new idea. People have been talking about this for a long time. But the advances in how virtual machines can be created and managed is one area that gave a boost to this discipline. And the other thing, of course, is networking. And I'm not biased being with a networking background, because the ability to move information very fast, reliably between different places allowed for people to create all kinds of virtual infrastructures. So virtual machines, containers, clouds, outsourced middle boxes. So middle boxes, from a networking technology, network terminology point of view, middle boxes are network nodes that are doing some network functionalities. And we're starting to see a trend where instead of doing this on a piece of hardware, you're doing this on a virtual entity somewhere in the network or in the cloud. And there is very good work on actually how, very good ideas that were proposed on how to do this. Network slicing is another technique or another terminology where you have different virtual networks and then you start to link them. So in this case, it's not just one virtual entity running on one cloud. You actually have multiple virtual entities, multiple virtual subnetworks or networks that you try to link in order to create an overlay to support a certain function. And of course, there is the trend of software-defined networking that I'm going to explain briefly in a few minutes, where instead of doing everything by dedicated hardware, we are relying on software to define and manage the network. And a virtual infrastructure could involve some of these elements or all of them, or it depends on what the application, what scenario we are looking at. But you will see that being manifested in so many environments. And that is the reason why people are moving to virtualized infrastructures or virtualization in general. So from the point of infrastructure, it's cost. So talk to somebody who's running a business, and then you tell them there is actually a way that you can move your IT operation somewhere else where somebody else will take care of it. You don't have to pay for the updates or the installations, and in terms of the day-to-day management, of course there is a debate, do we want to give up control over our IT, but cost actually is one factor that comes into play. Service deployment speed is another factor, and if you talk to somebody who is running a network, and then you talk to them about the fact that you can create new services and install them by just doing some software updates, some software installations, rather than all this big hardware setup, the idea is really appealing. There are problems and there are issues, but there is an appeal to the fact that things will give you the flexibility that usually comes with software. And of course, there is the element of innovation. If services could be deployed faster, or if you have an idea that's deployed faster, then it will give you more chances of creating and trying more things. In academia, for example, with software-defined networking, we were pretty excited when we started to look at this area. Because for a long time, you will come up with a very cool networking idea, a new routing protocol. But how can you implement it? You don't have the means of creating a piece of hardware to do that. And even if you do, you can't experiment with it because it will require a large infrastructure for you to set up. There are you can think of other ways of looking at virtualization and why they are important, but when you talk even to end users, even now, elementary school kids, they don't have to worry about moving their files from school to home, and all they need is a browser to access their homework. And they have, once they finish or close the browser, their homework or whatever they're working on is saved, they move to the other location and it's there. So it's as easy as that even for users who are being introduced to using IT. For somebody who's running a large IT operation, there are of course much more complex issues, but there is a big appeal there is a strong appeal to why you do this. So at the heart of virtualized infrastructure is the use of SDN, software-defined networking. It's becoming a critical tool in these environments because instead of relying on hardware, you rely on software, and this presentation is a short introduction to the area. So once you move to a virtual infrastructure, we have to deal with the changing notion of a network perimeter. And this is not a new thing. It must have been, at a certain point in time, it must have been the main concern of somebody running a computer operation where there was no network is there is a big computer room, mainframe or something, and the main issue is who gets physical access to this room. The computer was not connected, right? And what information, what pieces or devices or documents you can take in and out of that room. Then you connect this computer to the network. And then you have to think about how you secure this. You can think of securing the host itself, but then you have to define a perimeter for your network. And there's a good discussion about that in Cheswick's firewall book, host security, perimeter security. You'll have to define a perimeter that defines your network. And if you say, okay, I'll start by thinking which routers are connecting me to the outside, I will put firewalls, I'll create a DMZ, all of these techniques that people use in the networking, now we started to see things that are punching holes in our definition of a network. You started to see people taking the laptop home. So you're securing everything within the network, but somebody will take your laptop home. And then maybe they will have access to things at home that you actually do not allow within your network. Or they will bring your USB key to your device, to your network. Then your network perimeter is not as tight or not well defined as it used to be. Then we saw the trend of bring your own device. People want to bring their own cell phone and connect to to the organization network. How are you going to define your perimeter in this case? Then we started to see, okay, now let's consider the cloud. Let's move our IT to the cloud, or part of it. And then you have issues, of course, security and privacy and all, but there are two main things that will define this move. The first one is you're giving up control of some of your IT operation. And the second one, once you go to the cloud, depending on what kind of cloud service you get, you are sharing this infrastructure with somebody else. Your virtual machine might be sitting on the same physical server with somebody else's virtual machine, depending on the setup, of course. And we started to see some very interesting work, for example, on side channel attacks. So how do you define your perimeter in this environment? Again, another challenge. And then, of course, well, like a recent trend is to use network function virtualization. Instead of defining your network functions in hardware, we're actually seeing this moving into virtual machines. I will run the firewall on a virtual machine somewhere in the cloud. So you consider all of these factors, and then you think, okay, so how am I going to define a perimeter in this virtual environment? So with this in mind, I will start to move to define what is software-defined networks, which is using software to define the network in such an environment. This is a very abstract definition of, this abstract example of how networks work. So on the left-hand side, this is what I call traditional network. Each one of these boxes here is a box that represents a router. So we all know what a router is. So the network node that is moving information around. Anything we send on the internet is divided into small messages we call packets, and the routers are moving these packets around. So there are so much that is going on at any given router, but I can think of two main functions that I want to focus on today. The first one is how to forward these little messages, these little packets. So there is a forwarding decision that needs to be done. Router gets a packet, looks up some table and says, okay, the best way to send this packet to the next hop is to send it on that interface, on this link. So we call this the forwarding function, or the data plane. These red or orange parts of the routers, of the different routers, they are doing the forwarding plane. They are doing the forwarding function. How do they actually come up with this table that they are going to look up? This is where the control function comes into play. The control function, the network control, is the part of the router that talks to other routers and says, okay, if I want to send this to Carlton, the best next router is actually to send it this way. The control function will come up with this forwarding information and will push it to the forwarding table. So as you can see here, every router is doing its own control by talking to other network nodes, and it is making this control decisions, sending them to the forwarding function so that the forwarding function can do the actual packet forwarding. In software-defined networking, the main concept, when you actually read about software-defined networking, is the separation of control and forwarding. So instead of getting every router to make its own decisions, we are taking this function and making it a central function. So there is as you see here on the right-hand side, software-defined networks, there is a control function. This is what you call the network controller. And the solid lines are the actual links, the actual physical links between the routers. The dotted lines is what we use to send instructions to the forwarding plane. So what happens when you do this? First of all, you actually don't have to have very expensive hardware or very advanced hardware because the control has been taken. So it should be simpler. The second thing is you actually can make decisions where you see the entire network. You can introduce new functions. And that actually brings me to the next point, because now we took the part that makes decisions for the whole network out of the network or out of every element. If you want to introduce a new function, think of the controller as a network operating system. You will create your own application, it will sit on top of the controller or will talk to the controller, and the controller will handle talking to the individual elements. There is a lot of appeal in this in terms of introducing the speed or the time it will take to introduce new services. So having said that or having seen that, so what could happen with security? Of course, there's so much that could happen when you move from traditional network to SDN. Here I'm giving some examples of what could happen. The first one is controllers become very critical assets. So you need to take care of their security, right? Because if they are not behaving very well or they are compromised or something, it will be a problem. The second thing, there is a chance for poisoning attacks. So if somebody, instead of trying to DDoS the controller, try to poison the information that the controller sees, because in order for the controller to function properly, it needs to have a quote-unquote good view of the network. And we've done a lot of work in order to see what is a good view of the network, and I'll get to this in the next point. So one point here in the picture, I showed you just one controller. And of course, if you're running a network, you'll not have just one controller. For reliability, for example, you want to make sure that this controller goes down, the network doesn't go down. So what we use is what we call them, the term that we use is logically centralized controllers. So you have multiple physical controllers, and between them, between the controllers, we need to sync their state in order to see the same picture or a good picture of the network. So if they are sending conflicting rules to the routers, to the forwarding elements, it will be a problem. If they are collecting state, because they need to see actually how many packets did you forward, how many packets did you drop, how much traffic do you see, they always talk to people, to the forwarding elements in order to see that. If they get the wrong information, if they don't have the right state, or they're not synchronizing properly, this actually could lead to problems, performance problems in any application that runs on them, whether it's a load balancer or an IDS. And there is also some talk about benefits. It's still to be seen actually what benefits it will bring, SDN will bring to security, because we're still trying to figure out how SDN will actually work. It is being used in certain environments, but using it in bigger, wider, big-scale networks is still, the talk about SDN benefit to security is still new. So one thing actually where I've talked about how the controller is an important function, an important element, it actually, the fact that it could see the network, the wide network, this could actually help in having a better view of the network. If there is a network event and the controller sees that, it will be easier for somebody to create a monitoring activity or monitoring application on top of that. Has that been widely deployed? We still actually need to see that. New security functions, as I actually showed, that if you want to create a new function, instead of going to every single router and telling the router this is how you should filter traffic, you can create an application that will talk to the controller to push these instructions, new instructions to the routers. Again, there will be performance issues in terms of delays and so on, but it is something that is worth looking into. And the real-time updates, when you actually see a change in traffic, and we have done some work on that, where we looked at how you load balance, there is an attack on your network, how you load balance the attacking traffic in order to keep the network functioning somehow until you find some other intervention method. There is more discussion on this as well, but in conclusion, we're seeing a tremendous push into using software to manage infrastructures because of the flexibility, because of the reduction in cost, because of the speed of introducing new services. But definitely this will come with new questions, new challenges, and perhaps maybe new benefits to security, and this is something that is still to be seen. How this is going to evolve, we still don't know, but you will hear a lot about software-defined networking and network function virtualization, because this is something there's a lot of people are considering. I'll wrap up before I see the sign, and I'll be happy to talk to you afterwards if you are interested. Thank you.